Good evening, everyone. Can you hear me?
Yes, ma'am.
Yes, ma'am.
Okay. So, I guess it's already too late. So, we'll start the
Yes, the
session.
class is going on, ma'am.
Oh, okay. So, you want to wait?
Yes, little bit. 5 minutes more.
Maybe we can just recall what we did in the previous session till they join.
Yes. The last question left only. Last question is left. Of stars 2.
Which question?
Stars
Oh,
2
okay.
class is going on.
Okay.
So, sir, was the last question. I did it and came.
Okay. Maybe we'll be ready to start and we can join.
Hello, ma'am. Before we start, could I ask a
Yes.
question?
Sure, please.
Yeah. So, ma'am, in the About page, we have been prescribed 2 textbooks.
Okay.
The Disenroth, Faisal, and Ong, no, the Mathematics for Machine Learning book. So I downloaded it and got a print of that book. I just wanted to understand which chapters are relevant for the Maths 2 course,
I guess for the Maths 2 course, I'm not very sure about this book, the machine learning book, because I haven't seen the book. The vector
Right.
calculus, this has everything that's discussed in our course.
Okay.
I
So I
think
think
the mathematics for machine learning actually gives a machine learning perspective.
Yeah, so it is, ma'am, in 2 parts. Part 1 is just contains the mathematical foundations.
Oh.
So it has 3-4 chapters starting with linear algebra, then analytic geometry and matrix decompositions, then vector calculus.
We will be doing linear algebra part and multivariable calculus. Yes, that will be in vector
Right.
calculus.
Okay, so I should maybe refer to linear algebra chapter and vector calculus, right? In this case.
Yes.
Okay.
And the first
Okay.
3 weeks, that NCRT book is sufficient. Will that be sufficient?
Yeah,
Along with
actually,
your content, of course.
Yeah, the course itself is self-contained in the sense if you just watch the lectures and solve all the questions, all the assignments, that should be
Actually, that
sufficient.
itself, a lot of content is there.
Okay, so it's not part of the course, right? It's just for additional reading that they have suggested, is it?
Yes.
Okay.
But after third week, which topics and all will be there? Any Indian author?
From
which
third
we
week,
can
we'll be
relate?
starting with.
Sorry.
From third week, we'll be starting with the hardcore linear algebra, vector space. It's the one that I was.
Okay.
Yeah. That will go on up to week 9, I guess.
Okay. For that, which book you suggest?
Actually, there are a lot of good books for linear algebra. One is this linear algebra. The title is linear algebra. Friedberg.
Okay.
And there's one more author. So Friedberg, linear algebra.
Okay, means it is readable, man. These books and all, because
this is good for problem solving thing. But the thing is,
some exercise problems also, like.
Yeah, but the thing is, for the content that we are covering, means for the level that is needed for this course, this may be a little. I'd not say hi-fi. You will actually you'll enjoy linear algebra when you read this. That's for sure.
Means it will be in simple language explanation, or
yes, everything
they will skip
is
some
simple
steps,
there.
or we have to. Means what I mean to say is, they should. It will be like we should not assume.
It may not be too much in detail. Yeah, you might have to sit and do some thinking to understand things.
Ma'am, also I had gone through some video lessons for by Professor Gilbert Strang of MIT. So it's a very popular course in linear algebra.
Yes.
So would you say in terms of difficulty level, we will have something similar or easier in
It
this
will be
course?
easier. What we are doing will be easier than that.
Okay.
Gilbert Strang,
Yeah, a little bit easier.
what is that? From which you are talking?
Professor Gilbert Strang, you will find it in MIT Open Courseware.
Okay.
I don't remember the course number now, but if you Google it, you will find it.
Yeah. Okay.
You just go on YouTube and put linear algebra by Gilbert Strang. I guess you'll get all the videos.
Yeah, it is available.
Yeah.
So actually, ma'am, you were telling about the after fourth.
Is it helpful, ma'am? Ma'am?
From fourth week onwards, what will be the chapter? Sorry, vector.
Vector space.
Okay.
From third week.
Okay, from third.
Yeah. Okay, then maybe we'll quickly start recalling. And by the time we reach the new content, the others would have jumped. Okay, so we had discussed about vectors in R2 and R3, how to add two vectors, how to do scalar multiplication of vectors and all that, right?
Yes.
Am I audible?
Yes,
ma'am. Yes.
Okay. So a vector in R2 will have two components, x, y, and if it is three components, we say it is an R3. So R2, the 2 denotes the number of components, and R3, 3 denotes the number of components. So vectors in R2 or R3 were added component wise. So if I had two vectors, then I'll add them component wise, x plus z, y plus w. And then scalar multiplication was again component wise, alpha x, alpha y. And what is a scalar?
It's a constant.
It is a constant.
Yeah.
Constant
Elements
any
of elements of R, real numbers. Yeah. So this was the scalar multiplication and this was the addition. This is how it is defined in R2 and R3. And using this, we defined matrices. Matrices are nothing but an array of numbers. So the order of the matrix is an m cross n matrix if it has m rows and n columns. We put the number of rows first and then the number of columns. And then we saw how to add two matrices. Again, it's component wise. Scalar multiplication of matrices, again, it's component wise. So all this is possible, means you can add two matrices of the same order if they are of the same order. This is, I mean, the order of the matrix. So you can add two matrices only if they are of the same order. And we also saw how to do matrix multiplication. How was matrix multiplication defined?
A number of columns in the first matrix should be equal to the number of rows in the second matrix.
Yes. So suppose I have a 1 cross 2 matrix, then I should definitely have 2 rows in the next matrix. So say 3, 4, 5, 6. And what will be the order of the resulting matrix product?
1 by 2.
1 by 2, ma'am.
1 cross 2, 2 cross 2. So this is fine. It works. So it is going to be 1 cross
1 by 2.
And yeah. How do we multiply?
1 into 3.
1 into 3 plus
2 into 5.
2 into 5.
Yeah. The first row of the first matrix with the first column of the second matrix. So 1 into 3.
I'll have a question.
Yes.
Ma'am, could I speak?
Yes. Please.
I'm unable to understand the difference between the scalars and the vectors. Vectors are also real numbers and the scalar is also real number. So x and y, these are all the real numbers, and alpha is also real number. So what is the difference?
So x and y are real numbers, agreed.
Of course. Yeah,
but when I talk about a vector, I talk about the vector x comma y. It's not x separate and y separate. You have more than one component. You have a set of real numbers put together.
Means x and y belongs to R square.
No,
This x comma y belongs to R2. Yes.
it's like defining
X
a
is a
point.
real number, y is a real number. Both are two different numbers. When you talk about just x, it is a real number. When you talk about y, it is a real number. But it is said to be a vector when they come together. You write it as a pair, x comma y.
Okay, all got it.
And every vector, what I mean by R2 is I have a pair of numbers, each of which belongs to R. That's why I write it as R2.
Okay.
Relating to this only, there is an activity question in 1.1, question number 8. So I don't understand why V4 is not a scalar multiple of A plus B. Sorry, V3 is not a scalar multiple, but V4 is. Means I could not understand.
Question number?
We just activity 1.1, question number 8.
8. Which one is, what is your doubt?
My doubt is, ma'am, V4 is a scalar multiple, but V3 is not. It's why?
Okay. What is A plus B? What is A plus B?
This is 1 and comma 0.
1 comma 0, right? Where is that on the xy plane?
That's it.
P4.
X-axis.
X-axis, right?
Yes, ma'am.
Yeah.
Can you see that V4 is a scalar multiple because it lies on the x-axis?
Yes.
But V3 does not lie on the x-axis, right? So it's not a scalar multiple.
Okay, but ma'am, if we do this thing parallel test, then this is between A and B. So
No. What does scalar multiple mean? You have to do this.
okay.
Suppose you take any vector on the x-axis, it's going to look like this, right? The y component is going to be 0.
Yes, ma'am.
So a scalar multiple of this will be alpha times x comma 0, which is alpha x comma 0. It should still lie on the x-axis.
But had it been only addition, then that would have satisfied.
Had it been addition in the sense?
Means the addition between A and B vectors, then we could have.
No, A and B. When you add A and B, you get the
V4.
vector V4.
Okay, I didn't think of.
Ma'am, I do have some doubt on in activities. Can I ask now? Or shall I wait?
If it's from 1 to 3, you can ask now.
Yes, ma'am. 1 to 5.
Which one?
Ma'am, actually, in this case, last question 9, 10, no? I just open the mic tab and I tell ma'am. Just give me 1 minute.
Yeah. Is the stat 2 session over?
Ma'am, actually, it's going on now. Another 5-10 minutes will go continue.
Ma'am, I have a doubt.
Yeah, shall we finish?
9 or 10 question. 9 is only one. Ma'am, activity question 1.1.
Yes.
Question number 9. Just tell me the way how I should solve this.
Sir, this is solved with this.
No, this is active.
Okay, can I explain so that?
Yeah, sure. Please go ahead. Answer.
3a plus 3b. So you multiply b with 3, okay, plus c comma c comma c. So we have already given 4, no? So 3b means 3 2s are 6. 6 plus c equals 4. So c equals.
Actually, it will be really difficult if I only hear the audio. Yeah, if can someone share the screen?
Yeah, only thing is just multiply 3 with b coordinates. That's it.
So you have
I
three times.
can share my screen.
Excuse me, ma'am.
I don't think sharing screen is enabled, right?
Excuse me, ma'am.
No.
Yes.
Yes.
It is recovered.
Ma'am, this is not solved with this.
Yeah, solve this.
So
No,
we
this
are
is AQ.
ma'am, but in calendar it is showing solved with
Yeah,
us.
ma'am.
Yes,
Ma'am,
it
this
is showing
session is
Oh, the
solved.
session. Okay, fine. I thought you were asking about the assignment.
No. Are we going to solve new questions, ma'am, on joint PD?
Yes, ma'am. Yeah, we are waiting.
Yeah, we will be discussing determinants in the session, and we will be solving problems related to it.
Okay.
In joint PD?
No. So in maths 2, we don't do that.
Okay. Actually,
Okay, we
maths
will
1
solve
we did,
this
ma'am,
activity
actually.
questions only.
Yeah, we will be discussing
maths 2,
concepts and yeah. So in maths 2,
Ma'am, can you
basically.
please explain activity question 1.2?
Yeah, sure. 1 second. So in maths 2, what we will be usually following is we will discuss the content, means we'll do a quick recap of all the things that have been discussed in that week and solve problems related to it. So we will try to split the content into 2 sessions and 1 session completely for doubts.
How do we solve the
and we will
questions?
solve the questions that will be in activity and practice assignment, not new one.
Any doubts you want. Yeah, we will include a few questions, but in general it will be mostly from these assignments.
Okay, fine, ma'am. Fine. Thank you, ma'am.
Yeah, so the person who was asking question number 9, is it clear what you should be doing?
No, ma'am. Can you please do it here, please?
Yeah, so what was A? 1, 1, 1, 2, 1 minus 1.
Ma'am.
3 times 2, 1 minus 4. Yeah, so
Ma'am,
how?
C into 1.
Okay.
Yeah.
So how will you do this scalar multiplication? Can you tell me? Whoever asked the doubt.
Ma'am, that scalar will be multiplied to each component, like C1, C1.
C into 1, C into 1, C into 1. So we'll get this. And then what will happen here?
6, then 3 minus 12.
Yeah. And then how will you add these two vectors?
C plus 6, C plus 3, C plus 12, C minus 12.
Yeah. And then this is given to be equal to some vector, right?
Oh, yeah.
OJK. Yes. When are two vectors equal?
When the orders, it will be like C plus 6 is equal to 4. C plus, and C
That's
plus
it.
3.
You know how to solve.
Okay. C minus 12, okay.
C plus 6 is 4. From there you will get C. And then with that you will get J and K.
Okay.
Okay. Someone was asking about AQ 1.2. What was the doubt?
Can I ask a question, ma'am, in the 1.1 itself?
Okay.
Still, my doubt is not cleared. Why V4 is the... I understood that V4 is the... sorry. Yeah, I understood that V4 is the scalar multiple of A plus B. I'm not able to understand. Yes, 1 comma 0 and...
What is A plus B? A and B are given.
Yes.
So what is A plus B?
That's why it is in Excel.
These two vectors we have to add it.
Yeah. Yeah, you add A and B,
okay.
you will get A plus B.
Yeah. Okay.
It is 1 comma 0, right?
Yeah, it's 1 comma 0.
And we can also visualize in this. So like in like
okay,
we are shifting that
part,
B to head of A, and we will get V4. In that way also you can see. No?
Sorry, can you repeat what you just said?
Sum of two vectors is nothing but you complete the parallelogram.
Oh yeah, even that is also.
Yeah, but it's hard to visualize here. The best thing is just add A and B.
But generally, this first element will always be X, and second will be Y, and third will be Z. It will follow the same rule.
It's
like
ordered
coordinates. In
coordinates.
point, if we want to define a point, we call X comma Y. So X, we always put X
component first.
before Y. So it follows one precedence. So here also say X, Y, Z.
Yes. X component will be first, Y component next, Z component.
Okay.
Excuse me, ma'am. Can you tell
Yes.
the fifth question of activity 1.1?
Fifth question, is it?
Yes, ma'am.
Okay. So did you solve the previous question? I guess it's taking values from there. Following improved marks. Yeah, improving the marks. So you will get some answer from the fourth question, right?
No, ma'am, I don't understand fourth and fifth question. Please tell me.
Fourth question. Okay, for that we need third question, is it? Okay, there's some marking scheme that is given. Some they have obtained marks and all that.
Can I make one suggestion after this question? Can we go to the new topic? Means
Yes. I was
have,
going slow because they said start 2 session is not yet over. So I thought maybe we'll discuss this.
It's not that can clear everybody's doubt, but I think it was covered in 2 sessions before, even.
Yeah, okay. We'll just finish this and then start off with determinants. Okay. So in this question, the marks they have obtained is given, and then, okay, fine. In order to improve her marks, Farzana undertook project work and succeeded in increasing her marks. Her marks became doubled for each exam. Okay. So what happens if Farzana's marks become doubled for each exam? What should you do?
Multiply by 2.
What will you multiply by 2?
Multiply by 2.
What will you multiply by 2? So 38 into 2, 21 into 2, 35 into 2, right?
Yes.
So her new marks will be whatever is 76, 42 and 70, right?
Yes.
Yeah. So you will choose from all these, and then following Farzana's improved marks due to her project, all students were given bonus marks in quiz 2, which is given by the column vector. So every student is getting a bonus mark. The first student gets 10, the second student gets 12, the third student gets 15. What will be the column vector representing the final marks in quiz 2 by Karthika, Romi and Farzana? So for Karthika and Romi, the marks will just get added with 10 and 12. But Farzana's, you'll take her improved marks and then add with 15, right?
Yes, ma'am.
Is it clear?
Yes, ma'am.
Yeah.
Ma'am,
Okay.
I have a general question. Like, can I ask?
Yeah, sure.
Ma'am, in R3, if two planes are intersecting at infinitely many points, so those points lie on a straight line, na?
Yeah, two planes intersect at a line, right?
Okay, then
if they are one on top of the other, then it'll be the plane. But otherwise, the intersection is going to be, whatever is that line of intersection.
Then there must be an equation of that line.
Yeah.
So how can we find that line, the equation?
We will be doing that a little later, means in the later weeks. Yeah.
Okay, in week 2 or 3?
No, once we get into vector space, you will, when you study all these as vector spaces, you will be able to calculate the intersection.
Okay.
You'll get the equation. Yeah. Okay. Okay, fine. So I guess I needn't do this matrix multiplication. We'll proceed. So given a system of linear equations, it just means that we have a set of equations which are linear. Linear in the sense that the power of each of the variables is 1, right? So a system of linear equations can be represented in the matrix form as Ax is equal to B, where A is the coefficient matrix. You put all the coefficients of the variables as a matrix, you get A. The number of rows will denote the number of equations, and the number of columns denote the number of variables, right? Where each column corresponds to one variable. So whatever is the first variable, all its coefficients will come in the first column. Whatever is the second variable, its coefficients will come in the second column, and all so on. So we had seen all this, and then we had also seen solving system of linear equations, where we saw that a system may have a unique solution, no solution, or infinitely many solutions. So these are the three possibilities for a system of linear equations. The number of solutions for a system of linear equations. So we had discussed all this in detail in the previous session. If you're not talking to me, please mute. And if you're talking to me, please go ahead. Okay. So if you have any doubts in these topics, maybe you can watch the previous live session. Everything was discussed in detail there. So today we will discuss the determinants part. That is the last two lectures of week 1. So yeah, what is determinant, and how will you find the determinant? Can you find determinant of any matrix?
No, ma'am. You can find it only for square matrix.
Square
Yeah.
matrix.
So the first thing is it should be a square matrix. You can find determinant only for square matrices. So if it's a 2 cross 2 matrix, the determinant is very straightforward. How you find is you just multiply these two diagonal entries and then subtract the product of these two off diagonal entries. So if you have a 2 cross 2 matrix, you do AD and then minus BC.
BC.
So this is how you find the determinant of a 2 cross 2 matrix. And once we know how to find the determinant of a 2 cross 2 matrix, what we do is we can find the determinant of any higher order matrix. Okay, so if I have a 3 cross 3 matrix, what I will do is I will try to convert this into little 2 cross 2 matrices and then calculate the determinant. So if I want to expand along the first row, so for one thing, you can expand along any row or any column to find the determinant, which you will be studying in week 2. But in the week 1 content, it is you expand it only along the first row. Am I right? Or is it along any row?
Yes, ma'am. First row.
Okay. So along the first row, when you want to expand, what you do is you take the first entry and you eliminate the row and column that it comes from and calculate the determinant of the remaining submatrix. So submatrix means it is a part of this big matrix. So you write A11 into whatever is remaining. Remove the first row, first column. Determinant of this small 2 cross 2 matrix. A22, A23, A32, A33. And then minus, take the second entry. Remove the row and column it is appearing in, and the determinant of the remaining 2 cross 2 submatrix. So it's going to be determinant of A21, A23, A31, A33. And the last entry plus. So there's an alternate plus, minus, plus. So remove the first row and the third column. And then this is the left out submatrix. So A21, A22, A31, A32. So this is how you calculate the determinant of a 3 cross 3 matrix. So you expand along the first row of the matrix with alternating signs, plus, minus, plus. For the first entry, it will be plus. For the second entry, minus. For the third entry, plus. So is it clear how to calculate the determinant when the matrix is given?
Yes, ma'am.
Ma'am, for every n by n matrix, our ultimate aim is to break down into a 2 by 2 matrix and then find the determinant.
Yes.
Okay.
Yeah, here only I have confusion. See, for example, now you have stopped at 3. Okay, 3 by 2. And 2 by 2 you covered. And for 1 by 1, it is clear that it is the same thing.
Yeah.
Now, can you just put 5 by 5? Some example.
Maybe I'll do 4 by 4 so that
4 by 4. Okay, 4 by 4. 4 by 4.
So just say I have this. Something, some entries.
Something. Okay.
Yeah. So if I have a 4 cross 4 matrix, I'll do the same thing. Suppose I'm expanding along the first plus, minus, plus, minus. So now I will take this entry, eliminate first row, first column, because that is where it appears.
Here
now
only
I have a 3 cross 3 determinant.
So this full 3 diagonals I have to take?
Can you please mute?
Yeah. Actually,
so now I know how to find a determinant of a 3 cross 3 matrix, right?
Oh, again I have to split, is it?
Yeah.
Oh, I cannot directly take the diagonal 3 star into star.
No.
Minus 1 into star.
No, that's not how you find the determinant of a 3 cross 3 matrix.
Oh,
no, it's
okay.
different.
Again, I have to.
Yeah, you need to break down until you get a 2 by 2 matrix.
So that is the catch. Okay. So finally we have 2 only after we arriving at 2 by 2, then only we can do the diagonal process.
Thing. Yeah.
Okay. I was just doing diagonal minus diagonal.
Oh, okay. No.
Okay.
Yeah. So if it's a 5 cross 5, for the first entry, you will have to multiply that with a 4 cross 4 determinant, which you will do like this, for which you will take 3 cross 3 for that. So you'll keep doing till you arrive at that 2 cross 2 and use this formula.
Any easy method, because this is going to be a really big one to solve?
So this is the only way of calculating determinants, but there's one thing that there are certain properties of determinants which you can use, which may simplify calculating. But this is the way of calculating determinants.
But will you restrict only to 3 by 3? Or
yes, in this course we won't go beyond 3 cross 4.
Okay, that's good.
Even if it is 4 cross 4, it is going to follow some of the properties by which you will just look at the matrix and tell this is the determinant.
Okay.
Yeah.
So maximum is 4 cross 4 with we should know all the properties so that we can simplify.
Yeah.
I have a small doubt not related to this, but how do you find the trace of a matrix? I mean, just say we have a matrix, a square matrix, and they are asking us to find the square of the trace of its square or its cube. We just have to manually multiply and do the calculation, is it?
Yeah. Trace is nothing but sum of the diagonal entries. So for that, if you're asked to find the trace of a squared, then you should find a squared and then find the sum of the diagonal entries.
Graded assignment. There is one.
No, but there's one thing. No, to calculate the trace, you don't need the entire matrix. You just need the diagonal entries. So that's the.
But that is covered in week 1. No.
No, I think there was one question on graded assignment where you're asked to find the trace of some.
Yeah.
Yes, ma'am. There is one question.
Yeah, but that's a small matrix, right? It's a 2 cross 2 or something.
No, 3 cross 3, 1 by all unit. I mean, all the elements are 1, but it is a 3 cross 2.
Yeah. So you'll find a pattern.
Yes, a pass.
Ma'am, excuse me, ma'am.
Yes.
Ma'am, determinant is defined for the square matrix only. What about the determinant of the rectangular matrix, means m cross n, where m is not equal to n?
No, there is no concept of determinant for rectangular matrices. So only for square matrices I can talk about determinant.
So means this is only the square matrices, right? Thank you.
Ma'am, traces of matrix is studied in lectures.
No, there's nothing to study about this. So we just mentioned it in the question in the graded assignment that trace means sum of the diagonal entries.
Okay.
But you have not mentioned the name trace, no? You have not. You just.
It's there, I guess.
Actually, in the graded assignment, it's just mentioned sum of the diagonal elements.
That's what.
Then I think it's fine. Trace. But okay, I remember seeing trace somewhere.
Of a matrix is called trace. So.
Here it's given, no trace. In this question. Okay. Not everyone will get the same question.
Okay.
Yeah.
It's randomized.
We did not get the same.
Yeah. Okay, fine. So back to determinants. How will we calculate the determinant of this matrix?
3 into 1 minus 2
minus-
into 1 equal to 1.
3 into 1 minus 2 into 1. So this is going to be 1. So if it's a 2 cross 2 matrix, it's pretty easy to find the determinant. Okay. Can you quickly tell me what is the determinant of this matrix?
0.
0.
0, ma'am.
0.
Okay. Then this one?
0.
0.
0.
0, ma'am.
This one?
0.
0.
0, ma'am.
Is there a pattern?
Yes,
Yeah.
ma'am.
It's a multiple
It's
of
a
the other.
scalar.
Yeah. One
Scalar
row
multiple
is a scalar multiple of the
Multiple
other.
of the other.
Yeah. Same happens for columns as well, right?
Yes. Yes.
Yes, 0.
Yeah. So if one of the rows is a scalar multiple of any other row, then the determinant is going to be 0. Similarly for columns, if one of the columns is a scalar multiple of the other, then the determinant is going to be 0. Okay. How do we calculate the determinant of this matrix? Or which of the following options are right? How do I do it?
The first and second
First
options
and
are correct.
second.
First one, second.
I had
Third
a
also.
doubt in
Option
this.
C and option A.
Yeah, I had a doubt.
Option A, B,
A
D.
is correct. Direct only.
A and C is correct.
C, there is
A, B,
C.
and C.
C is also correct. Correct.
Oh, so here we are expanding along any other row also, right? This row.
changing the row.
Changing
and
the rows. Yeah.
row.
So how will B
Column.
be correct? I don't know because the sign is wrong, right?
No. We have made the
We
transition.
are
We'll check,
switching
we'll
the
check.
columns.
Here we are changing
Changing
Second.
the
Okay,
and
okay,
change the
okay.
row. No column, sorry.
Row. So minus.
That's why
minus
it
into-
became.
Then what
Okay.
about
So
the
one thing is
option C?
scalar multiple. If any row or column is a scalar multiple of another row or column, then
That trend won't change.
Ma'am, this
the
part, can
determinant
you a
is.
little bit elaborate this, what you are writing now, scalar multiple?
Oh, okay.
Yeah, if you
If
don't mind.
any row or column is a scalar multiple of another row or column.
Okay, it will be constant times 3.
Yeah, so it's going to be something like this: A, B, alpha times A, alpha times B.
Alpha times. Yeah.
Okay.
If you have something like this, then the determinant is going to be A times alpha B minus alpha A times B, which is going to be alpha AB minus alpha A. So this is 0.
And same holds for 3 by 3 also, ma'am.
Yes.
Two rows are.
So A, B, C, alpha A, alpha B, alpha C, and then some D, E, F. So in this case, what happens is, because these two are scalar multiples, the little 2 cross 2 things that you get there, somehow it will end up in 0. So if you expand along the first row, it's going to be A times alpha BF minus alpha CE, right? This portion. Right? The determinant of this portion. Am I audible?
Ma'am,
Yes.
that
Yes,
question, ma'am, in
Or
that,
this is too much. Okay, let me write down. Yes.
ma'am, in that question, which one you select the option B? Does it follow the same scalar multiple, and because of that you?
No. I was just discussing things here, and I shouldn't have proceeded.
Okay.
Okay. Then minus B times determinant of alpha A, alpha C, D, F. And then plus C times alpha A, alpha B, D. Okay. If I have, how will I calculate the determinant of this? Can I take something common out of this?
Alpha.
Yes, ma'am.
Yeah.
Alpha.
If one entire row is multiplied by a same scalar, I can take it out of the determinant, right?
Yes, ma'am.
Yeah. So I can take alpha out from here, alpha out from the other two as well.
Just a question here.
Yes.
Is it same for column as well? Like
If
Yes,
a column, complete column is multiplied, we can take out, right?
Yes.
Okay.
So whatever we do for rows, everything holds for column as well. Okay. And then, is there any way I can cancel things out here? No, I guess we have to expand, and then you will see that it is going to be alpha times 0. So if any row is a scalar multiple of any other row, the determinant is going to be 0. Same holds for column as well. If any column is a scalar multiple of another column, the determinant is going to be 0. If you're given a huge matrix, maybe the catch is that some row is a scalar multiple of the other, which makes it much simpler to calculate.
Is it true only for scalar multiple, or for example, if we multiply and then add with some constant as well, this is true?
That is a determinant will
No,
remain the same.
the determinant will remain the same there. Here the determinant becomes 0.
Okay. No, not adding, I'm asking, multiplying and then adding, ma'am. Say, for example, alpha A plus C.
Then also determinant will be 0.
I mean, sorry, alpha A plus
The
beta.
determinant will be same. Whatever in the
Determinant will be 0 itself.
No.
Determinant will
There the
have
determinant won't be 0.
That will have a determinant. That is what. Only constant you have to multiply. If it is.
If you add something, then
Yeah.
determinant won't change. The same. Yeah.
Yeah, if you add something, that's fine. But
it's only for scalar.
Multiplication plus.
Excuse me, ma'am. I have a
If you are
doubt.
getting matrix B by adding some constant to matrix A,
Hello?
the determinant won't change. The determinant of
I
B.
understand
But I
that. My
think,
question is multiplication and then addition. Both, if it is there.
then it will
The
become
determinant
0.
is not going to be 0. It will have some value.
It will have some value.
Ma'am, in that case, I think the determinant will be 0 because 6 said that firstly we are multiplying.
No.
No,
it won't become 0.
2,
It
3,
won't become.
4. You want to multiply a row with some constant, say 3, 6, 3, 4, and then you want to add it with another row, so say 6, 10, 3, 4. The determinant is not 0 here. Right? 24 minus 30. It's not 0.
Excuse me, ma'am. I have a doubt.
So it should
in the
be
previous
either
question.
one row or one column.
Am I audible?
Oh, so here you're doing some operation. I'm not telling you should do some operation. See, in this case, 6, 10 is not a scalar multiple of 3, 4, right?
3, 4. Right.
Yeah, exactly.
Similarly, 6, 3 is not a multiple of 10 and 4.
This is not some alpha times 3, 4. Similarly, 6, 3 is not some alpha times 10, 4.
Okay.
If it was, then the determinant would have been 0.
Hello, ma'am.
Yes.
Ma'am, I have a doubt in the previous example that you were showing. Can you go back to the sum?
We'll come back to this. We will discuss some properties and come back to this.
Okay, ma'am. I have the same question.
Ma'am, to be clear on what you said lastly, right? So if one row is a scalar multiple of another row and then you add with some constant, then will the determinant become 0?
No. See, in this case, what you did was you multiplied a row with a scalar. One row is not a scalar multiple of the other.
No, if we do as like that, like one row is a scalar multiple of other, in that case, I'm asking multiply and then also add with some constant.
Are you saying something like this, R2 plus alpha times R1?
Yeah.
Again, this year the
This is not. This does not mean that one row is a scalar multiple of the other.
Yes. But
it will have some value. It will have some determinant.
No. It will not affect the determinant if you're actually.
This won't affect. This is not going to affect the determinant when you do this operation. This I did not mean this is one is a scalar multiple of the other. This is not what I was talking about at all.
Okay.
Yeah. So in this matrix, what I was telling was, is the first row a scalar multiple of the second? No, right? 1, 2. The vector 1, 2. Is it a scalar multiple of the vector 3, 4?
No.
No, ma'am.
No.
So the determinant will not be 0 in the sense, yeah, like that is what I was talking about. I
If
wasn't
it was
talking
1,
about this
2
operation.
and 2, 4, then it will become 0.
If it was 2, 4, then 1, 2 is a scalar multiple of 2, 4. In which case the determinant will be 0. That's what I was talking about. This is an operation that's being performed. What I was talking about is about the original matrix, rows and columns. Is it clear?
Yes, ma'am. Yes, ma'am.
Okay. So that is one thing. Suppose I have a 0 row in the matrix. What will the determinant be?
0.
0.
Yeah. Why? Because you can expand along that row, right?
Yeah.
Yes.
Yeah. Okay. So
And
before that, yes.
I'm missing on few sessions. Like the open session that happened the other day, I didn't have any notification, or it was not even on my calendar that was synced.
No, you should add maths 2 course to your calendar. Only then you can see maths 2 session.
I am able to see this class and the first class, but in between there was an open session I couldn't attend because there was no notification at all.
Oh.
No, Friday, Saturday, Tuesday.
Yeah, that's fixed. Friday at 6 o'clock, Saturday at 2 o'clock, and what is today? Tuesday, right?
Tuesday
at 8
Yes, ma'am.
o'clock.
Tuesday.
Yeah. These timings are fixed for maths 2.
So Friday.
If there is a change, it will be announced. There won't be a change, but for some reason, if there is a change, it will be announced. And you should be able to see it on your calendar if you've added maths 2. Here, you will find.
Otherwise, you can put it in the announcement, ma'am. These are all fixed timings, ma'am. Because this is almost like 70-80%. This timings is going to be there. So just announce it. This is the schedule for match 2.
No, the calendar link is given, right?
Yeah. I mean, some students don't get that. So usually,
So where do you get it? You get it here, right? Somewhere about the course and at the end. Or something.
yeah. Somewhere here itself you can put what is the.
The Google Calendar link is here. You just click on this and add to calendar, and then you will be able to see everything.
And about the course orientation, that is not working. That link.
Oh, someone had posted it on Discourse, I remember. Someone had posted the link on Discourse. Maybe you can just search for course orientation.
Okay, no issues. Please continue.
Okay, I guess we'll continue with this and then.
Ma'am, did you say anything called a 0 row or a cluster or something
Yeah.
you told based? What exactly that
So
means?
suppose a matrix has a row, all of whose entries are 0.
Okay.
Then the determinant is going to be 0, right?
At 2022.
Okay. So in that case, we can say 0.
This is a 0 row, right?
And all diagonal and is 0, then it's also 0.
No. Diagonal entries has nothing to do with rows, no?
That is for triangular matrices. The multiplication of all diagonal
upper
entries.
triangular and lower triangular, then.
Oh, okay. Product of diagonal entries. Okay.
Yes.
That is for upper triangular or lower triangular matrices. But what I'm talking about is when an entire row of a matrix is 0 or entire column of a matrix is 0, then the determinant is 0.
It's like any row or any column, right, ma'am? Not necessarily first row. Okay.
Yeah.
Now, if you can
because of this operation.
Ma'am, if you can just look, because that's related to the above problem, if you can just look at activity question 1.4, fourth option.
Oh, okay.
Question number 4.
Okay.
I think
we'll come to this. We'll come to this because I have to discuss the changes that happens to the determinant. No, we'll discuss all this.
Okay. Sure. No problem.
So let's discuss the effect on determinants. So if I interchange 2 rows, can you please mute if you're not talking to me? Okay, thank you. So if you interchange two rows of a matrix, that's going to change the sign of the determinant. So suppose I have suppose I have 1, 2, 3, 4. What is the determinant of this matrix?
-2.
4 minus
Minus
6. Yeah.
4 minus 6. Yeah. So now suppose I interchange two rows.
+2.
My second row becomes the first row and my first row becomes the second row. In this case, since I already know the determinant of this matrix, I just need to change its sign. I need to calculate again. But even if I calculate, I'm going to get the same value, 6 minus 4. So this is not just for 2 cross 2, even for 3 cross 3. If you interchange any row, then the sign of the determinant changes. So now to this determinant, to this matrix, if I interchange again, or interchanging columns also changes the sign. So suppose I interchange the columns of this matrix, the sign of the determinant of this matrix will change, right? Not this matrix. Because you are interchanging the columns of this matrix. Yes.
Yes.
In 3 cross 3 matrix, if we change like one from row 1 to row 2, then I will change row 2 to row 3. Then it will remain the same determinant, or it will only change the ones.
You've made two changes, no? So it will be the first change. So the first change you are doing is, say you are interchanging the second and third row.
So it depends
now,
upon
whatever
the
is the
number
determinant, whatever is the determinant, you will do minus of the determinant. You want to interchange another set of rows. So now you are in a completely different matrix. From this matrix, when you change, the sign of this, the determinant of this matrix, that one's sign will change. So it will become D again. So two interchanges actually means you are multiplying, you're changing the sign twice. So you'll end up with the original determinant.
So it is something like -1 की power number of changes.
Yeah.
Into determinant.
Every time you make a change, you multiply by -1. That's it. So when you did the first change, you will multiply by -1. After the second change, one more -1. So ultimately, you'll end up with D.
Ma'am,
yes.
Can we like swap any row with any other row? Like,
Yeah. Any row with any other row. 1 with 3, 1 with 2, 2 with 3, anything is fine.
okay.
And even columns.
It's not applicable for row versus column, is it?
No.
If I interchange a row with the column.
No. You
1, 2,
cannot
3 is interchanged with 1, 7, 4.
In transpose, the determinant remains same, I guess.
No, the transpose means you interchange every row with every column. No.
Yeah, every row.
Not just one. Yeah. So you're not allowed to do row column operation. You can either do row operations or column operations. Okay, so that is one thing.
If in a square matrix, the diagonal elements are same, the det will be 0, right?
No, why? What is the
Okay,
determinant of this matrix?
Okay, 1.
Ma'am, I have a doubt.
Okay.
Yes.
Yes, ma'am. Suppose I'll can proceed the row multiple row operations and column operations on the same determinant at the same time or not?
Are you asking, can I interchange two rows and two columns at the same time?
No. Suppose first I interchange two rows in the determinant.
Okay.
Okay.
Like
Thereafter,
this.
I want to interchange two columns. Can it possible?
Yeah, you can.
Okay, right. Thank you very much.
So you do 2, 8, 5 and then 3, 9 or 1, 7, 4 and then 3, 9, 6. So what will the effect on the determinant be?
It will become D.
Positive D.
It will become D because you have to multiply -D with a minus sign. You'll change the sign of -D. From this matrix, you are interchanging two columns, so the sign changes. Okay.
That means like irrespective of whether you interchange row or column, only the sign of the determinant will change, right?
Yes.
Hello, ma'am.
Yes.
Can I ask from activity? Can I ask a doubt from activity question?
Yeah. Shall we discuss this and then go to activity, because it's just a little
Yes,
thing
ma'am.
that we need to discuss.
Okay.
Yeah. Okay. And then another operation which does not change the determinant is multiplying a row with a number and adding it to some other row. So the operation that we showed here, R2, if the second row is replaced with R2 plus some alpha times R1, then this kind of operation is not going to change the determinant of the matrix. Why do you think so? So 1, 2, 3, 4. Suppose I replace the second row with second row plus 2 times the first row. What will my new matrix be?
Six plus 1, 7.
6 plus 1. The first row will be the same. The first row will be the same.
Second row will be 5.
5.
1, 2, 5, 8.
5 and 8.
Second row will
5
be
and
8. 5
5
and 8.
5 and 8. There's an echo from someone's end. Can you please mute? Okay then. So this is what? 4 plus 2. Yeah. So this is going to be my new matrix. What it says is that the determinant of this matrix is going to be the same as the determinant of this matrix. So 4 minus 6 minus 2. Here it is 8 minus 10 minus. So why? Why so?
Madam,
Yes.
madam, what happened when we do like R2 tends to R1 plus R2 only, not linear combination. Sorry, not multiplied by some scalar, and
No problem.
only
It's the
R1
same.
plus.
Still the same.
Instead of considering it as R2, you can consider it as R1, R1 into R. Means 1 into,
Ma'am,
yeah.
ma'am, if we do something
Okay.
like R1 will be transformed to R2 minus R1, then the determinant will become minus of the determinant of the first matrix.
Yeah. So
Will it be?
Ri, the
Yes.
ith row should be replaced with ith row plus some alpha times the jth row. So Ri replaced with Ri plus something. The alpha has to be multiplied for some other row, not for the row that we are changing. In this case, the determinant does not change.
Yeah,
There is
even
one
if
more
alpha is
operation.
negative, nothing will change, right?
What is the reason behind it?
In this case, no change. There's one more operation where you replace the row with some alpha times that row. In this
Yes,
case,
yes,
there is
yes.
a change in the determinant. It becomes alpha times determinant of the previous. So you should be careful when you do this change. When you replace a row with a scalar, sum of the row and scalar multiple of another row, you are not doing anything to the row that you're replacing. You're only making changes, means doing scalar multiplication on row which is being added, some other row which is being added.
What is the reason behind it, ma'am?
Yeah, so maybe you should think doing it column wise will make it probably easier to check. Doing the same on columns may be easier to check. But anyway, you can think about it. You have A, B, C, D. Now, if you multiply a row with alpha, say I multiply R1 with alpha. So that's going to be alpha A, alpha B, C, D. It's clear, no, why the determinant gets multiplied with alpha?
Yes, ma'am.
Yeah, every term is going to have an alpha, so that will come out. Suppose I replace every row with alpha, then it's going to get multiplied with alpha squared, right?
Yes, ma'am.
Because an alpha comes out from every row. So if I have an n cross n matrix, then alpha times A,
Alpha to the
determinant of alpha times A is going to be
alpha
alpha
to the
power
power
n
n.
into determinant of. So for every row, I'm going to pull out an alpha, or for every column. we can treat it as rows or columns. But what happens when I do this? Say R1 is replaced with R1 plus 2 times R2. So what is happening? A, B, C, D. This is the matrix. It's getting converted into A plus 2C, D plus 2D, and then C, D. So in this case, what is actually happening? Here the determinant is AD minus BC. In this case, what is happening?
First row is being replaced by first row plus 2 times of second row.
I can write it as sum of two matrices, right?
Yes, ma'am.
What is the determinant of this matrix?
0.
Yeah. So the determinant of the matrix is not going to change, right?
Yes, ma'am.
Yeah.
That is the reason. So the thing, this thing that you're doing, yes.
Ma'am, how did you immediately break up this into two matrices?
I just, when you add these two matrices, you get this matrix, right?
Like that, that's reverse I
Ma'am,
heard.
we will get. Yes.
Sorry.
Yes.
And there's a mistake, 0.
Yeah.
It will be 0. Okay, 0.
Yeah.
Yes.
A
But
plus
anyhow,
2C,
still
B plus 2D.
A plus 2C. No, it is okay. Okay, now it's obvious. Okay, ma'am.
So when you do this change on one row, there is no change on the other row that you're doing. So you can split it into two matrices where one row is completely 0, right? So the determinant of this will be 0.
Yes, ma'am.
Yeah. So this is what happens when you do this kind of.
Excuse me, ma'am.
Yes.
Can we do an operation?
Ma'am, we can. Ma'am, we can write this matrix like. We can write this matrix like AB00 plus 2C, 2D, C and D. Can we?
A, B, 00 plus
2C, 2D, C and D.
Okay.
And then the determinant will be 0.
C and D.
No. See, determinant of A plus B is not equal to determinant of A plus determinant of B. No. Okay. If that is how you interpret it, that's not the reason. That's not the reason why this is happening. Okay. I shouldn't write it like that. Yeah. It might get wrongly interpreted. Okay, fine. So, what is this?
Can I ask one question, ma'am?
Yes.
Ma'am, can we replace both rows? Like we replace row 1 with R1 plus 2 R2 and R2 with R2 plus 2 R1 simultaneously. And
yeah, you can.
And there will be no change in determinant.
Yes.
Okay, ma'am.
Yeah. So we cannot tell anything about determinant of A plus B with respect to determinant of A and B. So what we can tell is only about the product. Determinant
Yes, ma'am. The addition thing is with matrices only.
This is not equal. Can you give me an example where this does not hold?
Ma'am, you take one identity matrix and another one will be -1 0 0 -1. Suppose you take 2 by
minus identity.
Yes.
2 cross 2,
In this
right?
case,
If it's
yes,
3
ma'am.
cross 3, it won't work. Any even order.
Yes, ma'am. In this case, the determinant of A will be 1 and determinant of B will be 1 and determinant of A plus B will be 0.
0, yeah. So this is the thing. But okay, what I meant here was not in case of determinant. Okay, fine. It was my bad.
Ma'am, I have a doubt here.
Last example.
Why this will not work for 3 by 3 matrix, ma'am?
Yes. What was this case? It's a 2 by 2 and 3 by 2. What difference will it make? Means,
what is the determinant of a 3 by 3 identity matrix minus identity?
Ma'am, I guess 1. 1 and minus 1.
Is 1.
1 and minus 1.
Yeah, and minus 1.
So it's going to be 0 0, no? 0 is equal to 0, no?
Yes.
That's why for this it won't be a counterexample. That's it. So any even order should work.
Okay, okay, yes.
Okay, ma'am, I got it. Thank you.
Yeah, so let's get back to those operations. And, yeah, this one we discussed, the determinant of a new square matrix obtained by multiplying a real number with a row or of square matrix of order n is c times the determinant of the original matrix. So if you multiply by a scalar c, then the determinant is going to get multiplied by c. Okay. Yeah, so multiplying does not change the determinant. Yeah. So what is the determinant in this case? AD plus 2CD plus minus BC minus
2CD.
So you have this AD minus BC and then these terms get cancelled. Why does it happen? I think it's easier to see when it is columns. Say C1, C1
2 by 2
plus.
matrix.
Huh?
It is 2 by 2 matrix, so it happened.
No. Even in the other, even in the general case, why should it happen? Why?
Ma'am, can you repeat the question?
My question is why doing this operation, say R1 is getting replaced with R1 plus 2 times R2, why doesn't this change the determinant?
Because we're keeping the R1 same, because we're keeping the same row, and again we're following the properties, one of the properties that is Scalar multiplication of the another row. So we are not doing any, like it doesn't in practical, like in actual it is not changing anything because we're keeping the same row, and again we're adding with another Scalar multiplication of the row, which is already one of the property of the determinant. That is the reason it is not changing.
And next thing is that crisscross determinant itself, it is a crisscross adding, multiplying and difference between the multiplication. So we are adding in the single row, so it is getting cancelled.
Yeah, exactly. You're changing only one row, no? Means you're doing some operation on one particular row. So because of that, yeah, whatever you said, that's what is actually happening. Things are cancelling out, and because of that, there is no change in the determinant of the original
Got
matrix.
one example before also, I think.
Yeah, we saw examples, no? Like say 1, 2, 3,
Alpha,
4.
and then
If I want to replace R2 with say R2 plus 2 times R1, then I'll get
1, 2.
Oh, we did the same thing, I guess. Earlier. Yeah. 3 times. If I do, then that's going to be 3 plus 3, 6. 4 plus 6, 10. So again, it's going to be minus 2. There's no change on the determinant because of this operation. But if I replaced R2 with 2 times R2 plus 3 times R1, in this case, what will happen?
Become the 2 times of the determinant.
Minus
2 times
6.
minus 2.
Ma'am, if we have a 3 cross 3 matrix, and then we do R2 will become R1 plus 2 R2. Sorry, R2 will become R2 plus 2 R1. And
no change.
R1, yes, and R1 will become R1 plus 2 R2 at the same time.
R2 plus 2R1.
2R1. R1 will become R1 plus 2R2. And we are doing it at the same time.
It doesn't matter, no, whether you do it at the same time or simultaneously, successively. We can take a 2 cross 2 only, right? We'll do 1, 2, 3, 4 only. So R2 plus 2R1. So that's R2 is getting replaced with 5 and 6. And R1 is getting replaced with 1 plus 6, 7. 2 plus
8, 10.
So what is this?
42 minus 50.
Minus 8.
Minus 8.
What did we do wrong here? R1 is 2 plus 2. 4, right?
R1.
Oh, no, 10, right, okay.
True.
Ma'am, R2 is 5 and 8.
Oh, fine. What? R2 is?
5 and 8.
5 and 8, ma'am.
Not 6.
4 into 2, ma'am.
R2 is 4 plus 4, 8.
8.
But then there's still something wrong, I guess. R2 is
6 plus 2.
4 plus.
Ma'am, when we are doing the second R1, we have to use the changed R2, right? The new
Yes,
R2.
Yeah.
Yes,
R2.
ma'am.
I think R1
We
11.
are using the previous
11.
Yes, ma'am.
6
11
plus
18.
2 into R1.
The new R1
Yeah.
is 11
R1
So you should get
some
4, I
7
guess,
plus.
right? 56 minus. Yeah, you should get 4. Yeah, that's because what are you doing? When you do this operation, there is no change on the determinant. But now when you do this operation,
Yes,
there's a 2 that's getting multiplied with, right?
Here R1 is changing, I think, in second time.
2 is
R1
getting
or R2?
R2 will
R2,
change
R2,
for
sorry,
R1.
R2. Yes.
Oh, yes, ma'am.
Ma'am, 2 is
It will
not.
So
become.
this cannot be applied in the same time to two different rows. It has to go through a consecutive manner, not
Yeah.
simultaneous.
Okay, yeah, if we do this operation on the new row that we just obtained, then it will be the same. Not on the old matrix.
Ma'am, but in
But if
3
it was
cross
a
3
3
matrix,
cross
doing
3,
together it works.
yeah, that's
Ma'am,
because you won't be
ma'am,
disturbing
actually,
a row, no? If you do the same thing on a 3 cross 3, okay. See, this is because R1 and R2 are getting thing. Like if I do say R3 is R1 plus R3 plus R1 and R2 is R2 plus R1. In this case, I'm leaving R1 undisturbed throughout, right? So that is taking care of the determinant not change.
Okay, ma'am, I think in that case, R1, after transforming R2, R1 will become R1 plus 2 whole into R2 plus 2 R1.
Yeah.
So, yes, ma'am.
Yes, ma'am. I just solved it and I got the same determinant.
For which one? For this one, is it?
Yeah, for this one. So 1, 2, 3, 4 has a determinant of -2, and then first I did the conversion for R2, then I did for the conversion for R1. Then finding the determinant, I'll get -2 only, the same.
But when I do it simultaneously, what happens? It's not the same, right?
It's not the same.
Yeah.
Because the R1, the R2 that I'm using for the next step is the old R2, not the changed one.
Yeah. So in this case, we are disturbing every row. There are only 2 rows and we are disturbing both. When we leave at least one of them undisturbed, that is when our determinant is not changing, right? That is the reason why some of the terms are getting cancelled off with the existing terms, right?
Ma'am, this rule is just a pattern, or there is some proof of it?
There is actually a proof why this is happening. You can, I think you will get it in the NCERT textbook only. Why the determinant does not change.
Until we are not disturbing any row, it will okay, madam. We are changing.
Yeah,
it
at least one of the rows.
Yeah.
Ma'am, if we do like R1 will become R1 plus R2 only, then after transforming the R2, like above,
R1 will be 2. Okay.
then will it become 3 times the determinant of the first one? I mean,
Let's check. R1 is R1 plus R2. So that's 4, 6. R2 is R2 plus 5, 6, 4, 4, 8. 32 minus. Yeah, I think it's because of this number, no? This number being 1 here.
Yes.
Yeah.
If we
But we are not
replace
allowed
that
to do this operation.
If we replace that second change of R1 tends to R1 plus R2 with the R1
alpha.
plus 2 R1 plus R2, so that will give us 3 R1 plus R2. So what we are actually doing is we are changing R1 into multiplying it with 3 and then adding R2 in the original condition. That is why our determinant is getting multiplied by 3 as well. So we are getting the answer as -6 instead of -2. So the second formula and the second property and the third property are getting utilized in the same time if we are doing the operation.
Yeah, something like this.
Together. Yeah.
So we are allowed to do only this. We will be studying elementary row operations. So in that we are allowed to, oh yeah, week 2 you would have already studied. So in that you're allowed to do only this.
Ma'am, there is a line mentioned in NCERT that if more than one operation is done in one step, care should be taken to see that a row that is affected in one operation should not be used in another operation. Like that is.
Like this, right? The one that is
Yes,
getting
ma'am.
affected shouldn't be used again. Yeah.
Here R2
So
is
this is
affected
okay.
both times, so it will not work now, ma'am.
Yeah. Here this is allowed, but this is not allowed, right? Because it's getting changed and we are using that here. This is not allowed.
Yeah.
Whereas if I keep this R1, it is allowed.
Okay. Yeah, right.
Ma'am, on the left side, which one you made it cross? For what exactly that means? Could you please repeat that one?
We are not allowed to do this. Means one R2 is getting replaced, and we are also using R2 to replace some other row, right? So this is not allowed. Means it can be on one side of the arrow in some sense.
Okay. Thank you.
Simultaneously, it cannot be on both sides of the arrow. Okay. So, and then determinant of A transpose is determinant of A. Yeah. And then if there is any 0 row, the determinant is 0. It's clear, no? Why? Now I can expand the determinant along any row, right?
Yes. Yes.
Because I'm allowed to interchange 2 rows, and that is only going to change the sign of the determinant. So in that case, what is happening? I start with a plus minus plus, So if I interchange, and then it is going to be minus, plus, minus, plus, minus, plus. So if I'm going to expand along the second row, what am I doing?
Then
Second row.
Minus, plus, minus.
Second column and second
So
row.
if I'm expanding along the second row, since I know
Then
to
minus.
multiply means expand along the first row, I will first interchange the columns, interchange the two rows. So that is going to multiply the determinant by a minus sign, and then I'll do plus, minus, plus, right? Right?
Sorry, ma'am. Sorry, ma'am. I didn't get
Ma'am, can you explain it once more?
Ma'am, ma'am,
Okay.
it will be
We
more
will ignore
clear.
this. Yeah,
It
we'll
will be
ignore
more,
that. This is clear, right? Plus, minus, plus, minus, plus, minus,
ma'am.
plus, minus. Yeah. So let's follow this only. You can expand along any row or any column, but this is the sign pattern that we have to follow.
Yes,
Okay, ma'am. But the interchanging part, I'm not getting.
I think
Ignore
that
that.
comes
Ignore
from
that.
that minor and cofactor.
Yeah, it comes from there. So that will
Ma'am,
be in week 2.
Ma'am, this one, can you please
No,
give an
ma'am,
Minors and
week
cofactors
itself,
are there in week 1.
Oh,
Yes,
they're
ma'am.
there on week 1, is it?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Oh,
The last topic of week 1.
Last video was that.
oh, okay, fine. So what is a minor?
Minor is the determinant of
the particular.
After
You
eliminating that
eliminate
corresponding
After
row and column.
Elimination.
So if you have a 3 cross 3 matrix, if you want to find the minor of a particular entry, what you do is you eliminate that
row and
particular
column and row.
Row.
And then whatever is the remaining entries of the matrix, you just find the determinant of that. That is what is the minor corresponding to this entry. And when is it a cofactor? What is a cofactor?
Minus 1 to the
Cofactor is
power
one
I plus j.
minus 1 the whole raised to I plus j into
that minor.
Cofactor is signed minor. You just multiply with minus 1 power I plus j, where I and j denote the index. The ith row and jth column of the entry. And then you multiply with that minor, corresponding minor.
So in this case, it will be minus 1 to the power of 4.
Ma'am,
minus 1 power 4, yes.
Ma'am, by using this minor and cofactor formula, we can directly calculate the determinant by expanding in any row?
Any row, any column, yes.
Okay, ma'am. We did not need to change the rows or columns?
No, nothing.
Okay, ma'am. Thank you.
Yeah. So that is the reason why we have this plus, minus, right? Because when I take the sign to calculate the cofactor, what is it actually? A11 into cofactor of A11 plus A12 into cofactor of A12 plus A13 into cofactor of A1. This is determinant, right?
Yes, ma'am.
Because cofactor of A12 will carry a minus sign. When we are expanding, we put a minus sign here instead of plus. Yes. Then we replace cofactor with minor. That's it. So for this reason, you can multiply, means expand the determinant along any row or any column. Yeah, so with all this in mind, we'll solve this. So in the first option, 3, 2, 2. So it's the first row. We are expanding along the first row.
Ma'am, that last one you told, no, I could not catch you. Can you please
repeat? Which one?
Ma'am, that plus minus plus then minus plus minus, that sign you've shown, and after that you've shown that I minus 1 to the power I plus c multiplied by minus.
That's the cofactor, right?
Ma'am,
that's how you calculate the cofactor.
That is the middle one only, it becomes minus, right? Not the all factors. Because when you're calculating the determinant, like only A11 becomes a plus and A12 only becomes minus, right? Not,
yeah, because 1 plus 2 is 3, minus 1 power 3 will be minus. So this will be minus. A21 will be minus similarly. A23 will be minus. A32 will be minus. Everything else will be plus.
Okay.
Right?
Okay.
1 plus
for
1
the
is
odd power, it will be negative. even power, it will be positive.
If the sum of the indices are odd, it will be minus. If the sum of the indices are even, it will be plus.
Okay.
Yes,
So this one, expanding along the first row. Plus 3 minus 2, 2. For 3, it is going to be the determinant of 3, 2, 1, 1. Is as it is. For 2, it's going to be determinant of 2, 2, 2, 1. It's as it is. And for this entry, it's going to be 2, 3, 2, 1. It's as it is. So this is the usual way of expanding the determinant, right?
Yes.
Yes.
Okay, what about the second one? 3, 2, 2. Again, first row, but the 2 does not have a minus sign. So is there something that's changing? 3, 2, 1,
Yeah,
1, 3,
the row, the column.
So here you have interchanged 2 rows, right?
Yes, yes.
Or columns.
Columns.
Interchanged 2 columns.
Columns.
Because because of that there is a minus sign which is getting compensated with this minus.
Yes, ma'am.
Okay.
So it becomes plus. Everything else is the same. What about option C?
The entire matrix column got changed, I think.
You expand along the second row. Minus 2, 3, minus 2. So in the second row we start with minus, right? Minus, plus, minus.
Okay.
So this is 2, 2, 1, 1. 2, 2,
Okay,
1, 1.
ma'am.
3, 3. 3, 2, 2, 1.
Yes, ma'am.
3, 2, yeah. And then for this entry, it is 3, 2, 2, 1. 3, 2, 2, 1, as it is. Option D, 2, 3, 2, which is second row. This should have a minus sign. For the second row, we should start with a minus sign, right? Because of that, this option is wrong.
Hello, ma'am.
Yeah.
Can you explain option C once more?
So for option C, we are expanding along the second row. So for the second row, we start with minus, right? So plus, minus, plus, minus, plus, minus, plus, minus. For the second row, we start with a minus sign. So
Excuse
minus
me,
2.
ma'am. Ma'am, I didn't get option B.
Shall I finish option C and then go to option
Okay,
B?
okay, ma'am. Sure.
Yeah. So minus 2 into the determinant of this matrix. Oh, not this one. 2, 2, 1, 1. Is option C clear now?
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am. Yes, got it.
Okay. Option D, it's same as option A, just that there's a plus sign instead of a minus sign, right?
Yes, ma'am.
That's because the determinant of this matrix, you're interchanging the columns of this matrix. So because of that, the determinant gets multiplied by minus 1. That is affecting here.
Okay, ma'am, I got it.
Yeah.
Hello,
Ma'am,
ma'am.
option D, can you please
Yes.
repeat it? Ma'am, option D, actually, which row it is saying 2 minus 3 plus 2? It is.
It's the second row. You should start with minus sign. It should be minus 2 into.
Minus.
Hello, ma'am.
Yes.
Ma'am, please, activity 1, question number 5 and 6. Please.
Yeah, I'll do it. There was someone else asking about one of the
Yeah,
options.
ma'am,
Right?
before that, similarly, we can also take the third row as the first, calculating the determinant.
Yes.
Okay.
2
Any
times
row we can take,
determinant of
regardless of.
2, 2, 3. Yeah, any row, any column. Minus 1 into
Okay,
3,
ma'am. Thank
2, 2, 2. Plus 1 into 3, 2, 3. Yes. Option? Option B or D? Okay. Can you please repeat?
Ma'am,
Hello.
option D, ma'am. Option D.
D. We are expanding along the second row, right? It should have started with a minus sign, like in option C. Minus, plus, minus. Okay.
Ma'am, I am on option
B. Okay, in option B, everything is same as option A, except that there's a plus sign here instead of the minus sign here. But you can also see that the matrix here, 2, 2, 2, 1, has become 2, 2, 1, 2. So the columns are interchanged. Because of that, there'll be a minus sign in the determinant here. That is getting multiplied here to become plus.
determinant of A equal to minus of determinant of A.
You're interchanging the columns here, so the determinant gets multiplied by a minus sign.
Determinant of A equal to minus of determinant A. This property will apply here.
No, which one? Determinant of?
Transpose equal to minus of
No. Determinant of AT means you mean A transpose. This is equal to determinant of A. No, we are interchanging two columns here. See, the first column is becoming the second column. Second column is becoming the first column. Because of that, there is a change in sign.
Easy, ma'am.
Clear? Yes.
In such questions, the operations that we have to check for will be in the determinants. This like the three determinants in the option. That matrix we have to check, or the original given matrix over there.
Oh no. See, here it's basically
Because
on this matrix.
while I was solving, I kept trying to figure a match with the original matrix, like which one they have switched or changed, and I got confused.
If you expand along the first row, then you'll multiply 2 with this matrix, right? So the operation is done on this matrix.
Only the sub matrix is being changed from in the first and second option.
Yeah.
Okay.
Madam, could you show this 3x3 transpose, madam? Matrix of 3x3 transpose.
You want the transpose of this matrix, is it?
Yeah.
So you just, the first row becomes the first column. Second row becomes the second column. Third row becomes the third column. This is the transpose.
Ma'am, in this question, all the determinants option A, option B, option C must be equal. Huh?
Yeah. When you calculate the right side, you should get the actual value of determinant of A.
But in option A and option B, determinants are not equal.
No, you will get they are equal. How will they not be equal? 3 minus 2, this is 1. 2 minus 4 minus 2. 2 minus 6 minus 4. Option A, obviously you should get the same because that's how you calculate the determinant, right? You expand along the first row. You can check. It'll be the same.
Okay.
Yeah. Okay, I guess we spent a lot of time on this question. Let's proceed to some other question. Then determinant of product of two matrices is product of their determinants. So this is one thing that's nice. And then, yeah. So if I multiply two matrices and I get the zero matrix, is it necessary that one of the matrices should be zero?
Yes, exactly.
No,
At least one.
No.
No,
ma'am.
No, ma'am. At least.
When
At
I
least the
multiply these two
determinant.
matrices, what do I get? What do I get?
Zero
matrix.
Let's do this. You'll get the zero matrix, but none of the matrices are zero, right?
Yeah, right.
Yes, ma'am.
Yeah. So this does not imply A is equal to 0 or B is equal to 0. But the determinant
can become 0.
It will be.
For
if
one.
determinant of AB is 0, then either determinant of A is 0 or determinant of B?
0. Yeah. Yes.
Because the
Yeah.
determinant is a real number, right? It's not a matrix.
Yes.
This is a
Yes,
number.
ma'am.
Okay. So how do we do this one? A is a 3 cross 3 matrix with a non-zero determinant. If determinant of 2A is k times determinant of A, what is the value of k?
8.
8, ma'am.
8.
Because a 2 is going to get pulled out of each row or each column. And there are 3 rows, so it's going to be 2 cube.
2 cube.
Yeah. What about this one?
Ma'am, please.
B and C.
4 and 5 and 6.
And
What?
B and
Can you
C
please
only.
repeat? Okay. So what is happening to B? What operation are we doing on B?
B, adding the first
Then
row.
And multiplying minus 1.
Does this change the determinant?
No, ma'am.
No.
No, ma'am.
No change.
What happens on C?
C1.
C also
C1.
same or the column.
C1,
C also
C1
same
minus
or
C2.
the column.
C1, 2 C1 minus C2.
Yeah.
Yes.
On D?
On D,
It's
it is
different.
We are doing
different,
something.
ma'am. Yeah,
It's
1 plus
something
and 1
different.
minus. Yeah.
On
E
E?
also, E also same.
The same.
Yeah. So you just expand D and E, you may get same answer. Okay, you won't get the same answer.
No,
So
different
B and
answer.
C. Yeah. On B and C, because these row operations don't change, row or column operations don't change the determinant, we get that B and C have the same determinant.
Yes, ma'am.
Okay. So the question, someone had asked something from activity question, right? That's similar to this problem.
No, ma'am. Practice assignment 1, question number 5 and 6.
Ma'am, this. I think
this question, the fourth
number
question. This is same as that, right?
Ma'am, actually, I think initially here the second row is 0, 0, 0. So that's why the determinant will become 0. Because we are firstly we are.
It's a scalar multiple, right? The second
Yes,
row is a scalar multiple of the first and third row.
Yes, exactly. So each and every element of one row is 0. That's why the determinant will become 0.
Yeah.
That means, ma'am, the determinant is 0 because it is the scalar multiple of first row.
Totally, we are removing one row, madam.
No, initially, ma'am. Initially here.
Is this separate?
A11, A12, A13, TA11 minus SK31, TA12 minus SK32, TA13 minus SK2. And then we have what? RA31, RA32, RA. So suppose you have A11, A12, A13, A21,
TA1.
Okay.
TA11.
TA12, TA13, RA31, RA32, RA33. So here the determinant is 0, right?
Yes.
Yeah. And then I'm doing a row operation on this. I'm doing R2 is replaced with R2 minus S by R, R3, right?
Yes.
Then I get this matrix. So
Yes.
by this operation, the determinant does not change, and I know that the determinant here is 0 because scalar.
Why S by R? S by R.
Oh, because there is an R here. I want to get rid of the R and keep only S.
Oh.
So, ma'am, basically here in this case, the determinant is 0.
Yeah.
Okay.
Ma'am, please. Active, practice assignment.
Practice. Yeah. 5 and 6.
Question number 5 and 6.
Okay, what is the doubt in 5?
Doubt. I can't understand, ma'am, this question.
Did you
How
check
to-
the assignment? The solution?
No.
Can you check that? Everything is clearly written in the solution. Practice assignments.
Okay.
Everything is solved in detail there.
Okay, ma'am. Please, question number 2 in this practice assignment. Question number 2.
Practice assignment solution, all questions are there on.
No, ma'am. I want to.
Okay. Yes.
Question number 2. Yes. Option 3. Option C.
Okay.
Yes. मतलब क्या मतलब
You
initiative
should
क्या
start
आना चाहिए
observing a
mediation?
pattern. Yeah.
कैसे करना
You
चाहिए?
calculate a squared, a cube, and then you see the pattern, and then you identify whether it matches.
मतलब ये 2 to the a to the power 10 is equal to 2 to the power 10. उसके बाद जो लिखा है ना जो 10.
Actually, what you can do is a equal to 2202. So first take out 2 from that. So you'll get 1101. And then when you try to solve a square, a cube, you get a pattern.
1101 कैसे आएगा?
Take 2 from.
See, 2 outside.
1102 ना?
Yeah, 1101.
No, 1101 ही आएगा ना.
From the matrix, if you are taking, then it will
मतलब 2
become.
square आएगा मतलब
वो
मैम.
determinant.
That is determinant. This is matrix.
Okay.
So try to find the powers here. What is a squared? Not a squared. This matrix squared. 1101. So that's 1201. And then when you multiply once again, you'll get 1, or maybe you'll get a 2 extra or something. That's why you're getting that 2 power n. Oh, no. That 2 power 10 will come from this.
Right in the mid of the page, no, madam. I am unable to see.
Okay.
Thank you, ma'am. Question number 6.
Yeah. Question number 6.
Thumb rule, madam, for a power 10, a power 5, we require to see pattern or
no, see, if it's something a power 10 and all is too much to calculate, so definitely there's something that's going to repeat.
After matrix multiplication, there is a 10.
What? After?
No, ma'am, no. Question number 6.
So, let A be a matrix of non-zero determinant, B be a matrix obtained by adding 5 times of first row of A to third row of A and adding 10 times. Okay. Do these operations change the determinant?
No, ma'am.
No. Yeah.
No,
So you
ma'am.
just have to observe that determinant of B is equal to determinant of A. That's it. And then calculate this.
Activity question 1.4, question number 8.
Activity 1.4.
4, question number 8. The hint they have given, what is that property means?
Okay, the matrix is in this form, right? You can do some row operations and check the determinant.
But what is this property means? Is there something special about this hint?
No. See, if you observe that if you try to sit and actually calculate the determinant of this matrix, it's going to be a tedious process.
Yes.
But once you have this 1, 1, 1, A, B, C,
A,
something.
B, C, B, and AB.
If you somehow do some operations and make it into a simple matrix whose determinant is easily calculatable, then you know what is A, B, and C. It's given, no? Some number. 2010, 2020, 2030. That way you can calculate easily. That's why this hint is given. Like you can make all these entries zero.
Can you please come up again?
After finding the determinant, we can substitute the values.
We find the determinant of this matrix first. R3 minus R1. So this is A, B, C, 0, 0, B minus A, AC minus BC, C minus A, BA minus BC. What is the determinant of this matrix? It's going to be the same as the determinant of this matrix, right? Going to be the same as the determinant of this matrix, right? And this one is easier to calculate, right?
Yeah, expand
along the first column.
Yes.
Yeah. Then you just substitute the values, whatever is A, B, C. A is 2010, B is 2020, C is 2030.
Oh, yes.
Ma'am, activity question 1.3, 6, question 6, 1.3, question 6. Just process how to begin with.
This we had discussed in detail in the previous session. Maybe you can watch that portion. You just have to substitute the values for K and then see whether they have a solution or not and all that.
Yes.
Also, ma'am, question number 7. I didn't get the.
Ma'am, you mean last
PR length.
Last session, have you discussed this question? Last session?
Yeah, in detail. All the options were discussed.
Hello, ma'am.
Question number 7, I could not get one length.
Which one? This one?
Question number 7. No, this is 1.4 activity. Question 1.4.
Question 7. Did you use this? The formula that's given here, half determinant of D?
Yes, ma'am. Yes, ma'am. The length one of the length I could find, but the other I could not find. PQ I could not find.
What value did you get for X? You will get two
QR
values, right?
Yes, ma'am. One negative and one positive.
One negative, one positive. Because X is greater than 0, it's going to be positive. Yes. Length, how will you calculate the length?
Sorry?
You do that square root of
x1 minus x2 the whole square.
Yes, ma'am.
y1 minus y2 whole square.
You do this to get the length.
Yes, ma'am.
Maybe you should just check the calculations. If you've got one right, definitely you should get the other right.
Hello, ma'am.
Yes.
Ma'am, actually, I am not able to understand a statement of graded assignment, some questions. Last question of graded assignment.
No, which is the question? Because it's randomized and...
Yeah. Question number... 1 minute.
No, not the question number, the question itself.
Questions. Questions are like 1 minute, ma'am. 1 minute.
Yeah.
Yes. Please open. Questions. Yeah, in discussion forum of Maths 2, one of learners posted the following post. Yes. I am not able to understand a statement of the option, ma'am. Actually, here it has mentioned a statement. Solution of C dot x is equal to b is given explicitly in term of solution x is equal to b. What is that meaning here, madam?
Did you open this post and check what it is?
Okay.
If you click on the post, you will understand this question. Like, click here to view the discourse post. You will be able to see the post.
And here it has mentioned, ma'am, counter example are given by counter example. If suppose statement is false, then counter example is enough to prove that it is false.
Yeah.
Okay.
Yeah.
And since you are there in the graded assignment, can you go up? I have one doubt. I'm not looking for a solution, but here there is a square matrix. Yeah, Aij. Yeah, seventh question. So if I take a square matrix Aij, no, there was a square matrix where A squared equals AC. One question was there. Can you go down, man? Yeah. Third. A squared equals. So if I take A equals 0, 0, 0, 0.
No, you shouldn't. You shouldn't take A is equal to something. A is any square matrix satisfying A squared is equal to A.
Yeah, that's what. So if I take a square matrix such that A equals A squared, then there are two possibilities. 1, 0, 0, 1. And
no, those are not the only matrices. There are a lot of matrices for which A
Can
squared
I,
is.
ma'am?
This is also such that A squared is A. Yes, sure, please.
Okay, so you
Without
need not
revealing the
consider,
solution.
you need not consider any matrix as such.
Uh-huh.
Just
Yeah.
expand
The formula
whatever is given and try. That's all.
yeah.
Oh, okay.
Yes, yes.
That was the
So,
answer.
ma'am, I had just one doubt. In the ninth question, the method we use is just to find the inverse by finding the adjoint.
Which one?
Ninth question, I guess, the same graded assignment.
In my assignment, is it?
Yeah. Yeah. So we need, for the solution, we need to find the inverse and then find the answer,
No,
right?
what is the inverse here? There is no inverse. No, this is a vector. No inverse. This
No,
is
but
just dash. This is not
yeah,
inverse.
that is the solution for the given set of linear equations.
Oh, okay, okay,
For
okay, fine.
solution, we can use the matrix inverse multiplication method also.
Yeah, you can do it any way you want.
Yeah.
Okay, any other questions?
Yes, ma'am.
So one question that asks to find A power 5, right? So do we have to multiply it 5 times and find, or is there any other
No,
way
no.
to?
If you observe a pattern, you should be able to answer it.
Okay, okay.
Ma'am, activity question 1.4, number 4.
Okay.
I don't know if we've already covered that. I was away for some time.
Yeah, I had discussed this.
Okay, I'll go back and check that.
Yeah, I had just discussed here.
Okay, ma'am.
Yeah. Any other questions?
There is one. When we perform a column operation, that is the same as row operation. Like if I multiply a scalar and then add to another column, the determinant does not change. But there is a question.
Whatever you did to rows, you can do to columns as well.
Yes. There is a question in activity 1 of 2, week 2. There is some confusion there. Means if you can do that, it is related to week 1, so that's why I'm asking.
Yeah, which one?
2.1.
Huh?
Can you just scroll down because I don't remember the question.
This one, is it?
Yes, ma'am. The first option. No, ma'am. Can you just scroll down? Yes, ma'am. This one.
These are the right options, A1 and A2.
So I selected A1, but it's not. It's saying A1 is not the right option.
I think it is updated now.
Achha, okay, that was the problem.
Oh, it's still not updated. Okay, I'll ask them to update.
Okay.
A1 and A2.
So that was the problem, ma'am. Yeah.
Ma'am,
Okay.
activity 1.5, question number 10.
Okay.
So A1 is the right option, right?
Yeah, yeah. A1 and A2 are right. Okay, what is the doubt here? What is determinant of B? Determinant of B is, you can calculate it straight away, right?
Yes, yes. Oh, okay.
Any other questions?
And A plus B whole cube, A plus B whole square, can we expand it like normal algebraic expressions?
No, no. So you cannot write 2 times AB. If I have squared, for example, A plus B whole squared should be treated as A plus B into A plus B. So that's going to be A squared plus AB plus BA plus B. these are not equal in general, right?
Yeah. And about whole cube?
Can you hear me?
Yeah, ma'am. It's clear. What about whole cube?
Anything. Even for square, if it's not going to work, then same with cube, right? When you want to do a cube, you have to multiply this with a plus b.
Right.
Okay, any other doubts?
Hello, ma'am.
Yes.
Have you solved question number 7 of practice assignment 1?
Practice assignment. Did you check the solutions of practice assignment?
Actually, my answer is not matching.
Huh?
My answer is not matching.
Did you check the solution that's given here? Practice assignment solution.
No.
I think you can. It's
Sorry.
just some calculation mistake you would have done.
Okay, ma'am. I will check.
Yeah.
Ma'am?
Thank you.
Yes.
Just a few minutes ago, you showed a plus b whole square equals to a square plus ab plus ba plus b square.
Yeah.
So yeah, this one. So normally what I do is like I write 2ab. That is not right, right?
Yeah, that's because AB need not be equal to BA.
Yeah. It's not always equal
When
to
we have numbers, AB is equal to BA, and that's why we write 2AB.
Okay.
Yeah. Any other questions? These questions are easy to solve, right? Can you quickly tell me which are the right options?
First one.
First option
First
is right.
one.
Second option is
Second
right.
option
Last
is
option is
correct, and
Last
Third
fourth
one
option.
is wrong.
Fourth option.
It's going to be the determinant of A into determinant of B transpose, but that's equal to
Determinant of
determinant
C.
Determinant. Correct.
And then this one, all the elements of a matrix are same.
It's 0. Determinant will be 0.
Determinant 0.
Option wrong, and
Option
option 4.
Option 4 is
no.
Option 4.
Option 4.
Option
Correct.
4 is right.
What is A plus A transpose? Again, you'll get same. All the entries will be same.
Yes,
Just that
ma'am.
the number will be twice. Yeah.
It will be 2 into A.
Yeah.
Yes.
This is all. Okay, fine. So done?
Excuse me, ma'am.
Yes.
Like in practice assignment.
Ma'am, can I ask a question?
Yeah, there's someone asking, right, in practice assignment?
Yes. No, like the first question I have solved it. It was about graphs, but when I looked at the like I only guessed it like by looking at whether they're matching or not, intersecting or not. That way I tried to choose the options, but then
Yeah,
the
that's what you should do.
The
If
solution
two
was
lines
like
are parallel,
like
if
the
two lines are
solution was
parallel,
given is very
then
lengthy. Should I do it that way also to check in exam, or like visual inspection should be enough?
I don't remember what the solution was.
Yes, ma'am. All this.
Okay, they're just solving it. Instead of just looking at lines, it's solved.
We don't need to solve them actually, right?
Yeah, you don't
just have
actually need to.
match
If you can just look at the equations and realize they are parallel lines, then it is done.
Exactly, ma'am.
Yeah.
Like if the values are marked on the graphs, maybe then we'll have to solve the x and y coordinates. If suppose
maybe. Yeah.
Then we'll have to solve.
Yeah. Okay. Any other doubts?
No, ma'am.
Okay, then I guess it's getting late. So for everyone, let's close then. Fine?
No, ma'am.
Ma'am, actually, some of the questions which, like after going through your solutions, which you have already done, would you be able to take those questions in comment sessions? Because what happens now when we go back to that session, maybe
Yeah,
sometimes
sure,
what
sure.
happens, we
We can
quickly select the
answer.
options, but you don't explain in detail. So that's the reason I like to repeat. Like today, some questions, no, you just quickly select and you did not explain in detail. So similar thing happened in the past sessions also. So will you be able to take those questions in comment sessions, please? Because if you
Yeah,
say
yeah.
that go back and say no, again it will happen the same thing that doubt will remain same.
No, see,
Actually,
these
ma'am
live
has described
sessions.
these sessions in last Saturday.
These
Ma'am,
live
can
sessions
you-
should only help you solve them better, like so that you put in effort. If everything is solved here, no, then you might not be able to. It might look easy for you when we solve it. So during the exam, it will be difficult for you. So unless you sit and solve, um, you won't be able
yes,
to
ma'am.
do
Actually,
exams well.
ma'am, actually, personally, I try to solve it, but I could not understand how to approach that one. So I just wanted to
So maybe
get
you
an
can put
idea.
it on discourse, because when you post it on discourse, I have put a long post telling that don't post answers straight away. So when we don't post answers and give you hints instead, you will also learn better. Like what is the approach? That is also. So discourse may be the best way if you are stuck doing something or you don't know how to start and all that. The
Ma'am, the
discourse link
discourse
is
link,
available on the portal. You have that discourse forum, that link, right?
ma'am, is
Is
it
my screen
available in the?
visible?
Yes.
This is regarding the
Yes.
mock test.
This for forum. Yes.
Okay. So, ma'am, then forum, in that forum only we'll click that discourse link.
Yeah, yeah. When you click on that, you will be led to the discourse map 2. This one. You can post your doubts here. You
Yeah,
just
okay.
click on
Thank you.
plus and then create a new post.
Okay.
Or you
Thank you,
can
thank
even
you,
check,
ma'am.
maybe your doubt is already asked by someone.
Thank you, ma'am.
And this is regarding the mock test.
Yes.
Week 2, can you a little bit do some additional sessions or something like that?
2 sessions will happen, no? Friday and Saturday. 2 sessions will happen on week 2.
Ma'am, will the score of that mock test will be considered for grading?
No, 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 no. This is just a mock test.
This will help for our quiz 1?
Yeah, definitely. You are going to revise 2 weeks, right?
Yes, yes, yes. Okay.
Yeah.
This will be timed one or how?
No, no. It'll be
Any
available
flexibility
throughout
is
the
there?
day.
Okay.
Ma'am?
And
Yes.
can we expect the same type of question? Sorry, can we expect the same type of question in quiz 1? Means mock test type?
No, we will give you a mock for quiz 1. So that will be similar to quiz 1 questions.
Okay.
Ma'am, last time we had bonus marks for live sessions.
This time I don't think it is there. You should check the document. I don't remember things from the document. So there's a document given, right, for bonus marks, giving all the details.
Will do, ma'am. Thanks.
Yeah. Okay, then I guess we'll close. Good night, everyone.
Yeah, thank you, madam. Thank you.
Thank you, ma'am. Thank you so much.
Thank you.
Ma'am, good night, ma'am.
Good night.
Thank you very much, ma'am. Good night.
Thank you.